Today I want to talk about inequalities and how we represent solutions or graph solutions for inequalities. First of all, how does an inequality differ from an equation? Well, remember, an equation was stating that two sides were equal to each other. An inequality, on the other hand, states that two sides are not equal to each other. Now, this can be done using different signs. So we can say that the one side is greater than the other or less than the other. Or sometimes we write it this way, that it's greater than or equal to, or less than or equal to. So for instance, if I want to get my driver's license, I have to be my age has to be greater than or equal to 16 years of age. Sometimes we use not equals to. Now I'm not going to talk a lot about not equals to, because when a variable is not equal to another variable, basically we treat it just like we would an equation. But I want to talk about inequalities. Okay, and I want to talk about something like this. How would we represent something like this that says x and then this sign and 2? Now, first of all, we got to remember how to read those. Now, if you remember how to read those, my wife's mother was a grade 1 teacher, and she'd say, tell them that this is a Pac-Man, and the Pac-Man always goes for the big one, or the alligator always goes for the big one. So in this case, x has to be greater than or equal to 2. And if we go back to our balance scales, and on the one side I have 2, and I'm thinking, okay, so what could this side be so that it's greater than or equal to 2? Well, it can't be 1, because that's not bigger than or equal to 2, but it could be 2, because 2 is equal to 2. It's not bigger than it, but it's bigger than, or it's equal to it. The answer could be 3, so 3 is one answer. Yeah, but it could be 4, or it could be 5, or it could be 6, or if I'm allowed to chop those blocks up, it could be 6.2 blocks, or 3.4 blocks, or all those different numbers. All of them could be solutions. So if that's the case, then how am I going to represent this? And we've agreed in mathematics that when there's more than one solution like this, instead of trying to write them all out, we're going to use a number line to represent our solution set. So here's what we do with our number line, and we don't spend necessarily a lot of time on our number line, but the important number in this case is 2. So I showed 2 on the number line, and remember here I'm looking for all the numbers that are bigger than or equal to 2. Now since 2 is equal to 2, I put a closed circle on 2, and that's my way of saying that 2 is part of the solution. And then I want all the numbers bigger than 2. Well, all the numbers bigger than 2 would be the numbers this way. And so I just shade that way and I draw an arrow, and that's understood to mean all the numbers bigger than or equal to 2, including like 2.1 and 3.4 and 6.5, all those numbers. So let's take a look at some other ones. What about this one, where it says now x is smaller than or equal to 2, or less than or equal to 2. So again, we put our 2, we're going to close that in because that's part of my solution. But now I want the numbers smaller than 2, so I would go this way. The numbers like 1 or 0, those are all smaller than 2, so there's my solution. Now what about this third one? X is bigger than or equal to -4. Now, so I put -4 in there, and I want the numbers bigger than -4. Now, here's the mistake most students make. So I say to them, what numbers are bigger than -4? And they say, well, -3 is, which is correct, and -2 is, and -1, and so on and so on and so on, and that's all correct. But what about -3.9? Oh yeah, that's a little bit bigger, right, because it's warmer. -3.1, yeah, that would work too. So how am I going to show those numbers? So again, we've agreed in mathematics that if I want to use -4 as a starting point, but I don't want it included in my solution set, I'm going to put a circle on it, but I'm not going to close it in. And that's our way of saying that -4 is a starting point, but it's not included in the solution. And when I shade that way, so that's my way of saying all the numbers that are bigger than -4 are included in my solution. Lastly, what about a fraction? And again, this one throws students, but it shouldn't. So my important number is 3/4. So here is 3/4. I want all the numbers that are smaller than 3/4. Now, that means 3/4 isn't included because 3/4 is equal to 3/4, not smaller than it. And then I shade this way. All right, and that's our way of representing all the numbers that are smaller than 3/4. So I'm going to ask you to try a couple of those graphs.